Hi everyone, this is practice formative of chapter 4, question number 17. In this question, we need to find the number of ways to arrange 7 different storybooks and 3 different magazines on a bookshelf. Okay, 7 storybooks and 3 magazines. Okay, if there are no conditions imposed, that means we can just jumble them up, 7 books plus 3 magazines, 10 items. So for part A, 10 factorial. Okay, we are looking for 10 factorial. Okay, what is 10 factorial? That is 3,628,800 ways. Okay, 3,628,800 ways to arrange the books and the magazine on the bookshelf. And B, magazine must be put together. So if magazine must be put together, they are considered one whole item by itself. So we need to arrange 8 groups of things, 7 books plus 1 group of the magazine. So we have 8 factorial, that is externally, okay? And among the magazine, 3 magazines, they will permute among themselves. So followed by 3 factorial. Okay, so let's use the calculator. 8 factorial times with 3 factorial. Okay, so the answer is 241,920. 241,920 ways to arrange. Okay, now let's say if you can't see, you want to fill in the slot. Well, yes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 items, whereby the 3 magazine we group it. So from here, it's very obvious. We have over here 7 plus the 1 here. So we have 8 items to arrange. So externally followed by internally. Externally, we have 8 items, 8 factorial, and internally 3, 2, 1, 3 factorial. So isn't it? It is the same as this. Okay. If you can imagine the condition, you go straight to this. Otherwise, just sketch it. Okay, so that you can see it. Part C. The magazine cannot be put together. If the magazine cannot be put together, so they must be separated. All of them must be separated. So we arrange the 7 books first. We will have 7 factorial. And then let's find how many empty spaces in between the 7 books. So you see, 1, 2, 3, 4, 5, 6, 7. These are books. And how many empty spaces in between them that I can put my magazine? So we have 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 places for me to choose to insert my magazine. So 8P3. Okay, so 7 factorial followed by 8P3. 7 factorial times with 8 empty slots for me to choose any of the 3. P3. So we have 1,693,440 ways. 1,693,440 ways. That's it. So unlike question number 16, to find the number of ways whereby the female cannot sit together, we take the total arrangement when there is no condition imposed minus the number of ways when the 2 females are sitting together. Question number 17, we can't do that because we have 3 items. So when the questions say the magazine cannot be put together, it means all 3 magazines must be separated. If we take the A minus the B, we may get the arrangement whereby 1 magazine is separated from the 2 magazines. And that is not what we want. We want the magazines totally not together, totally separated. Okay, so that is the reason we need to use fill in the space in between method. rather than taking part A minus the part B. Okay? So that's for question number 17.